One.
All right. Hello, everyone. So today, me and Peyton have created a Flex and Bison mini compiler. Next. So first, we're going to go over Flex, and then over Bison, and then all the basic stuff we did. So simply for Flex, Flex is a lexical, or sorry, a lexical analyst, which is a scanner that scans the input for the user and matches against a list of rejects PS provided by the creator. Next. For Bison, Bison is simply just a syntax analysis. So Bison works with Flex to complete the syntax analysis when given the tokens and then execution. Next. So we started off with basic arithmetic operations. These are the cream of the crop of compilers, your most basic functions. So here we got addition, division, multiplication, um, and subtraction. So Flex introduces the tokens being able to, or sorry, introduces the tokens to be able to be identified when typed in the command line, as you can see on your right-hand side. And then Bison, uh, as you can see here with the percent left, plus and minus, and then percent left, multiplication and divide. This sets the precedence for the operators, making the multiplication and the divide higher than addition and subtraction, much like we do with PEMDAS uh, for order of operation. And then on your bottom right, that's where the calculations happen. So you got your expression plus expression, so like 1 plus 2. And then on the right hand side in the brackets, you got the double dollar sign, which is for the total value, the dollar sign one, which is your first value, and then plus, and then your third value, which would be your second number. Next.
So the structure for all of these basic operations are going to be relatively the same. On this slide, for the comparison operators, you can see the top left image is going to be the declaration of those operators in the flex file, whereas the top right is going to be the declaration of those tokens in the Bison file, as you can see with the red arrows pointing to. For this, we define equals, not equals, less than, or equal to, greater than or equal to, less than, and greater than. In the bottom left, you can see, similar to those arithmetic operations, the declarations in the Bison file. Expression equals expression, expression not equal to expression, and it uses the same syntax with the double dollar sign, the dollar sign one, and the dollar sign three to make the actual comparisons. And you can see an example of all of these comparison operators working in the bottom right in our actual mini compiler. Variable storage was likely the most complex thing to get done, as it has a lot of different parts to it, as you can see. Up here at the top is going to be the flex definition for an identifier. You can see the first part of it is going to be A to Z, uncapitalized, A to Z capitalized, underscore. That's all the things you can start a variable with. And then the second part of it is going to be A to Z, uncapitalized, A to Z capitalized, 0 to 9, and an underscore. And we capitalize, or we put all of that into a character pointer. And then we use yyLval.id, and we make a duplicate of that string, and we return an identifier to the Bison file. So where does that identifier go? We can see in the middle left, there is both an expression declaration for an identifier where we just get the index of it and we assign the value of that identifier. And there's also a statement under the statement section identifier, where identifier and then an equal sign and then an expression. So this is used to set the value of an identifier. So like x equals 5 or something similar. In the top right, you can see the space that we allocated for our variables. So we define the max number of variables we can have, which is 100. We use a character pointer to delineate the variable names, and we just use arrays to capture the variable names and the variable values, and we keep track of how many variables we have so we can iterate through the get var index, which the function for the get var index is in the bottom left. You can see that we take just the name, we loop through all of the variables that we currently have. If we find the name, we return the index of the name. If we don't find the name, we see if we have room for a new variable, and then we create that new variable. Um, in the bottom right, you can see the general syntax for the symbol table. We use %union to delineate between values um, that are integers, character pointers, and doubles. Doubles are going to be used for trigonometric functions. Integers are going to be used for mostly everything else, and character pointer ID is the important factor for the variable storage. And you can see at the bottom there, every time we declare a token like a number, an identifier, or a float, we have to specify its union value as either dval, val, or ID. And here's an example of the variable storage in action. You can see we set x equal to 5, y equals x plus 2, that type of thing. It's able to store and operate on variables. As for logical operators, this is very similar to comparison operators, and, or, and not. You can see in the top left, we have the flex definition. Top right, we have the functionality. Bottom left, we have the Bison definitions, which are pointed to in the red arrows for and, or, not. It's important to know precedence goes from bottom up. So not will happen first, and then or. Um, that is just how logical operators precedents work. And then you can see an example of the logical operators working on the right side when actually compiled in the compiler. We use and, or, not, and a mix of all of them.
Alrighty, so trigonomic functions work very, very similar to the basic arithmetics, with just a slight change. So in these functions, both Flex and Bison need to have the math header included, since we're trying to achieve higher level functions. As you can see for Flex, we state the sine, cosine, tangent, cosecant, secant, and cotangent, all the same, just like we did, or very similar to, we did with multiplication, addition, divide, and so on. But the difference is we got to take into account floating numbers. So you can see in the top right where we got the symbol table. The symbol table is kind of like a global variable. And so in order to use those double values, we got to have the double dval in there to use across the flex and bison. Down in the bottom right, or sorry, down in the bottom middle, um, you can see where we have left bracket 0 through 9 plus. So that means you can have whole numbers such as 45, 2, 3, and so on. And then backslash point is your decimal, and then you're able to have those numbers again. So you're able to have like 45.3222222 and so on. And then as we go through, that just allows uh, the user and to export to the user the use of floating point numbers with YYL, VAL dot dval, and then ATOF for floating numbers. And then on the Bison side, it's pretty much the same exact thing. Um, so instead of just a regular expression, we got F expression for hours. So when you enter it, it'll be sign, left parenthesis, the number, and then right parenthesis. And then once you enter that, it will give you the number. And then hence the double dollar sign, which is your total. And then it grabs the sign function from the math header and so on. And then for the cosecant, secant, and cotangent, it's the same thing, but it's just 1 over sine or 1 over cosine or 1 over tangent. But it works the exact same way.
All right, so our control We used if-else statements. We tried to implement while statements, and that'll be discussed a little bit later. But you can see in the top left, we defined the keywords for both of our braces as well as if-else in the flex file. In the top right, we define blocks that we can use braces for. It's just braces and a statement list, and the statement list is just a reiterative function that allows multiple statements to exist inside of one block. The bottom left shows under statement, we have the functionality for if and else. If will happen, and it will print a value if the expression is true. And then if else will take the first value if the if statement is true, and the second value if the else statement is true. So it's relatively simple functionality for the if else statements. So going into some of our difficulties that we faced in our setup, we noticed that there was a huge lack of documentation on Flex Bison, and that was one of our difficulties faced in code as well. We tried multiple setups like Visual Studio and Ubuntu, and originally tried multiple different things, but found that Windows was just the easiest to use, given that it's native to both of our systems. Installations of Flex Bison and GCC on Windows was a little bit of a headache at points, and we resorted to ChatGPT for learning the syntax and structure of the code in Flex and Bison, again, due to that lack of documentation. But it is important to note that we did not prompt ChatGPT for answers, only for learning purposes, to learn things like the $ syntax, or some of the like YYL vowels, various things that are unique to Flex and Bison that we wouldn't know from our previous coding experience, and that it was hard to find documentation of. For difficulties in code, we didn't really have any examples to pull from for code, or to try and learn from, as again, it was very difficult to find things online. Code would sometimes work on one machine and then break on the other machine, and we didn't know why. That was present. Um, and some of the difficulties that we had in code came a lot with while loops and switch statements, which we tried to implement. In the files, there is some leftover code from those, but while loops ended up being very difficult, as we weren't sure how to get around the fact that $ statements don't reassign every time it loops through. We would have to do something with variables that we don't really understand given our inexperience in Flex Bison. But overall, we ended up being very happy with our implementation given our previous knowledge, which was none, and we think we ended up in a pretty good spot with our compiler.
So, in conclusion, Flex and Bison is really hard to code. Uh, Tons and tons and tons of trial and error. Again, lack of documentation made AI a pleasant option for learning the languages, and Flex and Bison is a good option if you're looking to simulate your own compiler, but be very, very prepared for a hard experience. And then proud of a finished product, like Payne said, and despite lack of some of the desirable features. Thank you.